So the notes are called equilibrium, constant. And what we're actually going to be doing tonight is writing our own equations, given some sort of a chemical equation. And the equilibrium constant is known as KEQ, where K is the constant, as K so often is, and EQ stands for equilibrium. Oh yeah, I forgot. I have something that I made you guys. Now, how awesome is this picture? Look, I drew myself. I think it's a pretty good drawing. Like, I'm pretty pale, and I have glasses, and I wear my hair down. So, we love chemistry. Yes, we do. We love chemistry. How about you? Okay, back to our notes. Anyways, basically, the overall formula for this equation is going to be KEQ equals products. Now, it's the concentration of the products, so I put it in brackets, all over the concentration of the reactants, and then each one is going to be raised to their coefficient. So raised to their coefficient. Just a reminder, let's say I have 2x, or let's say I have 28y. The number in front, that is what the coefficient is. So this 28 and this 2, those are the coefficients. So the coefficient is just going to be the number in the front. Let's go ahead and let's do the first example. So it says, find the KEQ expression for the reaction. And our reaction is going to be 3H2 gas plus N2 gas, equilibrium arrow, gives us 2NH3 gas. Okay, so the first thing I'm going to go in and do is, I know that there's technically a 1 in front of N2. And basically what we're doing is we're going to be making our own equation based off our chemical reaction. So for each chemical reaction, we're going to be able to make our own equation that tomorrow we're going to learn how to plug things into. So I'm just going to go ahead and follow the format. So KEQ equals, now it says the concentration of the products. So this is my only product, so it's going to be the concentration of NH3 raised to its coefficient, which happens to be 2. All over the concentration of my reactants. In this case, I have 2 reactants, so it's going to be the concentration of H2 raised to its coefficient, which is 3. And then the concentration of N2 raised to its coefficient, which is 1. Now, you don't really have to write the 1, but you can go ahead and do it if you want. I'm going to go ahead and do that there. Okay, and that's all we're doing today, is just taking these equations and using our equation in equilibrium and making a math equation we'll be able to plug into tomorrow. So example 2 is going to be find the KEQ, and our formula is going to be 2SO2 gas plus O2 gas, equilibrium arrow, gives us 2SO3 gas. So first thing I'm going to realize is technically there is a 1 in front of oxygen, so I'm going to put that there. and I'm just going to write the KEQ expression. So KEQ equals the concentration of the products raised to their coefficient. This is my only product raised to its coefficient, which is 2. So the concentration of SO3 raised to the 2, SO3 raised to the 2, all over the concentration of my reactants raised to their coefficient. So I've got 2 reactants, so the concentration of SO2 raised to the 2 times the concentration of oxygen raised to the 1. I'm not going to write the 1 in, but you could go ahead if you wanted. Let's do example 3. Find the KEQ expression. And we're going to say that this is CH3 COOH gas, equilibrium arrow, CH3 COOH. Actually, the second one's gonna be a gas, and the first one's actually gonna be a liquid. So just take that G and turn it into an L. Sorry about that. Okay, so this one's gonna be a little different. Notice all of the chemicals so far, they've been gases. Gas, 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 gas. Now something is a little bit different when you have a liquid. I'm going to point to the liquid, and I'm going to say liquids and solids. So that's going to be L and S are not, underline, underline, included in KEQ formulas / calculations because they are what is known as pure substances. So pure substances. And then a pure substance, I'm going to go ahead and define this, is it's at a constant equilibrium. At a given temperature. But all you really need to know is if it is a solid or a liquid, you're not going to include it. So the KEQ expression for this, KEQ equals products on top, the concentration of the products, which is, our product is a gas, so I can include it, CH3COOH, all over the concentration of my reactants. But unfortunately, my reactant's a liquid, so I cannot include it in this formula. So this is just our KEQ, just that. We're going to do one more example, and then we'll be done. So example number 4. And this is going to be the same problem, same thing I'm asking you to do. So it's going to be 2NaHCO3 solid is an equilibrium, so our equilibrium arrow, with Na2CO3, which is a solid, plus carbon dioxide, which is a gas, plus water, which is a gas. Almost ran off the page there. Okay, so they want us to find a KEQ here, and we just wrote down that we don't include solids or liquids. So this guy here and this guy here, I'm going to say do not include solid. And I'm going to do the same thing under this guy. Do not include solid. So they're just not going to be part of our KEQ. So once again, I have my formula. I'm just going to go ahead and write it out. KEQ is basically products over reactants. Okay? So my products that I can include, I do not include solids, are the carbon dioxide and the water. Now this is already balanced because there's a 2 in front here, which means that this equation is balanced. So technically there's a 1 here, a 1 in front of carbon dioxide, and a 1 in front of water. So here's my first product, hence it's products first. So my KEQ equals the concentration of CO2 times the concentration of water, because that's also a gas, so I can't include it, concentration of H2O, all over the concentration of my reactants. But unfortunately, my only reactant is actually in a solid state, and I don't include solids or liquids. So that is my final equilibrium expression. So all you're doing, really, is you're making these equations using the equilibrium, and then tomorrow night we're just going to learn how to plug things into the equations that you made. So once again, I'll leave you with this wonderful We Love Chemistry photo. Since I can't take a video of myself right now, I'll go ahead and leave you with this, and I hope you guys have a wonderful evening, and I'll see you tomorrow in class.